Alright, so today's video is going to be about Lesson 8 in your CAM Instructor book. It is going to be on the tutorial. So let's go ahead and get started. So the first thing I'm going to do is I'm going to go in, I'm going to select a machine. Of course, I'm going to select a lathe, not a mill. I'm going to pick my Haas ST 4-axis lathe because this has a Y-axis in it. We don't need it for this part, but you know, it's nice to have. So that's generally the one I pick when I do this. Plus, it's the machines that we have in the shop. You can also pick default if you do not have this post. Hopefully, you are or you have watched the video on how to add posts, and you've added some of these posts to your post processor files. But if you do not, default is fine. I don't grade that part of it. I don't grade what post you have selected. As long as you have default, default will work with anything. It'll assume that it has a Y-axis. It'll assume that it has a dual spindle if need be. So it opens up everything. If you pick this 4-axis, this will work fine too. So I'm going to pick this one since it's the machine that we have in the shop. Next thing I'm going to do is I'm going to go to my levels, and I am going to, oops, sorry, not levels, planes. And I'm going to go to my DZ plane and hit equals. Okay, so now I'm working on my DZ plane. All right, I am now set to start creating geometry. So I'm just going to go to my line endpoints. I'm going to do a multi-line. And this, you know, my strategy differs a little bit from what they show you in the book. I find this easier, so I'm just going to show you this way. So first place I'm going to start out is 0, 0, enter, create my line. Okay, next one is going to be at 1.0, 0, enter. Next one is going to be at, it looks like negative. Looks like it's going to be 1.0, comma, negative 1.5, enter. Then the next point will be at 1.45, comma, negative 1.5, enter. And the last point will be at 1.45, comma, negative 2.0, enter. Okay. I do not need to connect this. There's no real need to do that. The only reason I might do something like that is if I had like a profile back here, or if I wanted to maybe put a chamfer on the back side. And I can do that, as you may have seen in other videos, and I'll do it in this one. I'll put a small chamfer to deburr that edge on this back edge. I'll do that with my cutoff tool. All right, so I'm just going to hit check, and that is all you need. Now, of course, obviously I have to add my fillets. In this case, I have a 0.125 fillet here. So add that in and hit my blue check, and a 0.05 fillet right here. Oops. And hit check. Okay. So there is my part. That is all I need. Now, of course, I haven't put the hole or the points in for the holes yet. But that's all I need to turn the part. Next, as you can see, this is the first lesson that we're going to be working with any kind of live tooling. So we're going to actually do some cross drilling to this part. So we need to add some points or holes. Either one is fine. Points are a little bit easier because you have to add holes. Kind of have to rotate them a little bit differently. So first I'll start off by showing you points. So the easiest way to add a point is obviously there's going to be one up here at the top. It appears that's going to be a 1/4 inch in the negative in the Z. So we'll just say 1.0, comma, negative 0.25. And there is our first point. And now that I have that point, what I'm going to do is I'm going to take that point and I am going to go to transform, rotate, and I am going to select. Actually, first, I'm going to go to my end. So I'm going to go to my right face, so I'm actually rotating from there. And I actually like to rotate it just a little bit to see what I'm doing. And then I'm going to go to rotate. Select that, end selection. Okay, so now you can see I'm rotating around this axis, which is a little different than where I was. My angle is going to be 90, and of course I need 3 of these. Okay, so there we go. If you put 4 in, it will double this one, and when you select them, it will drill that one twice. So make sure you only use 3 if you're doing a rotate and an angle between. Okay, so we have our 4 points. So that is one way of doing it. So if you go back to top view, so there's my 4 points around the outside. The other way that you can do this is if you want to create circles, you can actually create a circle, and in this case it is an 1/8 inch it looks like. So I'm just going to put, well, first I'm going to go to my home, and I'm going to change my Z value here. So my first circle needs to be right here in the center. This is the easiest way of doing it, making it this circle. So I'm going to pick this one, not the one that I just made up here. I'm actually going to do a different one of my holes, and not the one down here. I'm just going to do this one here. So I need to technically be towards myself or towards me about 0.5 inches because that's where the hole lies on the diameter of the part. So I'm just going to add a 0.5 here into my Z, and this allows you to draw on a different Z level. Okay, so now I can put in my points. So I'll go to my space bar. Oops, I'm gonna get my auto cursor, here we go. All right, so I'm gonna put my points in, and that of course is going to be 0, comma, negative 0.25, enter. Oops, type something in wrong. Planes, I accidentally got into a different plane, that's what happened. Okay, so there we go, now I'm in the right plane again. Top, all right, now let's try that again. I'm going to go to 0, comma, negative 0.25, enter. All right, so there you can see, now I'm in the right spot. All right, so the radius of this hole is going to be, or diameter is going to be 0.125, enter, check. So if you like to use holes, that is how you do it. You can see that it's on that different Z level. It's 0.5 difference there. It's off by 0.5. It's actually in the Y-axis with the plane that we're working on. But when you use this command, it actually uses the UCS, or the Universal Coordinate System. So it's actually doing a Z towards you, and the Z is actually going through the screen. So that's how you do that. Then, of course, if I need to rotate these, I'm just going to go to the right side view, and I select it, and I'm going to rotate, and hit 390. And let's see what we get here. Tab. Check. And there we go. So now you have your 3 holes all around the perimeter. So you can use those. You do it that way, or you can do the points. I think the points, personally, is easier. Some people like to do this just for the visual. I'm not crazy about it. In fact, I'm actually going to create a point right here quick. Oops. I want to create that in the middle. There we go. And I'm going to delete these holes and rotate. Oops. All right, and I'm going to rotate this here around because I like the points much better. So we're going to go to transform, rotate, check. Okay, there we go. All right, so now we are ready to start machining this thing. All right, so the first thing I'm going to do, of course, is set my stock up. So I'm going to go into stock setup. My top plane, no, I want to be working on my DZ plane. My stock is in this spindle. All right, so it looks like I have a 1.45 maximum diameter. So I can cut this out of 1.5 inch stock. So let's make it 1.5. The length says 4 inches, so I'm just going to make this. And remember, I can leave this long, or I could also use my margins. I'm going to use my margins because I like to use those. I'm just going to make my left margin 2.0, and I'm going to make my right margin 0.01 because that way it'll show the face. So I'm going to hit check, and that looks good. Also, your tools, make sure you have assigned tool number sequentially. This may change when you take it out into the machine, as any of you who've had experience on the lathes know. You may need to change your tool numbers based on whether you have clearance for certain tools or not. So I always put this on just so they're in order, and then you can change them out of the machine as you see fit. So I'm going to make sure that's on. And it's saying that this part, well, we don't have a material, so we're not going to set a material. Oh, it does say aluminum, I'm sorry. So let's go ahead and change that to aluminum. Right click, get from library, and I think it's 6061, check. Okay. So everything should be set up well. The jaws, you do not have to set up the jaws. I showed you in the last 2 tutorial videos how to set the jaws up. If you want to do that, feel free to do it. Really, that's just kind of showing clearance, but you're going to decide that at the machine based on where you put your G54 or where you touch your tools off, or basically how far you have your stock sticking out of the spindle. Okay, so let's hit check. All right, so that stuff all looks good. All right, so now we can start running some tool paths here. So let's go to turning. Let's face this thing. I'm just going to use my 80-degree diamond for this. Facing max spindle speed. Of course, you know that the specs max spindle speed should be 3,000 in our machines. Spindle speed 200. We can run 900 surface feet per minute. And the feed rate is, we're going to say 0.005 for a face pass. We could run it faster if we wanted to. Everything here is good. This is going to finish at 0. Everything looks good. We don't need any lead outs. Computer compensation. We don't need compensation because we're only doing a straight pass. We're only machining in one axis. So I'm just going to hit check. And there we go. Next, we are going to rough this. So I am going to show you a couple of ways to rough this. Well, it's going to rough it the same, but we're going to use 2 different tool paths. So the first thing is we can do a partial here. So I normally just select this radius and here, and I'll hit check. And of course I'll select this tool again, 10 thousandths, 3 thousandths in there, and or 900. Obviously I don't have these set up, so I have to change them each time. Okay, so you can see here I do have my defaults in for a lot of this stuff, and again, if you want to know how to do that, watch the video on setting your operational defaults. Lead in, lead out. Let's go to this. So it's leading in fine. Do we want to extend the contour? No, not the lead in. But to lead out, we do want to extend the contour. So let's extend that a little bit further than the width of our cutoff tool. So let's make that 0.15, and let's hit check. Plunge parameter is not plunging, so we don't need that. Compensation type, we are going to put this on wear. So it is going to, or actually I'm going to put this on control. For the lathe, I like control because I can change my tool nose radius as a whole number. So in other words, if I were to put this on wear, and let's just hypothetically say that my tool nose radius for the tool I select in Mastercam is a 32nd. If it's a 32nd, it's going to program the numbers so that it's offset by a 32nd, and so that any number that you put in your tool nose radius will just offset it further. It'll almost be like a wear inside your control. If you just put it, well, the problem with that is, then if someone else goes and puts another tool in, you have to know what tool was originally programmed for so that you can put the correct offset in, because the offset would not be the number or the radius that is on the tip of that tool anymore. It would be the difference between the radius that you programmed in Mastercam and the radius that you're using. So that can get very, very confusing. It's a lot easier in the mill with end mills. because generally you're not changing end mills for the size. But in the lathe, you change tools just to change that radius so that you can get rid of chatter and stuff. So I recommend putting this on control and then just putting in your tool nose radiuses out there. So this is a little different from the mill. I recommend that being control. Disable stock recognition. We definitely want to use stock for outer boundary. And we're going to hit check. And you can see there we have our rough pass. So it roughs a little bit past where we need to be so that we have our clearance for our cutoff tool. So everything looks good there. Let's take a minute and run that. All right, play. All right, so that looks pretty good. I'm happy with that. Now you may be looking at this and saying, well, that radius doesn't quite look like a full radius. Why doesn't it look like a full radius? That's because we picked control for our tool nose compensation. It will turn out right on the machine. But yeah, sometimes your radii and stuff get a little funky with the graphics. So if you really want to see your graphics run right, you can go in here and put it on computer or put it on where, and then you can run your graphics again and just see, if it looks right. So you can see there now it looks more like a full radius. If we go to top, that actually still, yeah, it's just a graphic thing, but you can see there, it's a full radius. It's just a little goofy in the graphics. But you always got to remember to change that back. Otherwise, you're going to run into some issues with radii and chamfers. So I'm going to change this back to control. Check. Regen. All right. Now, that is the way that you've learned up until now to do a lathe rough. The problem with that is if we go to post code, and let's simulate this. Let's post some code quick. Sure. Just call it T. Yeah. And just give it a second. It'll pop up here. Okay, so here's our code. All right, so we can see here, tool 101, it's calling it up, coming down. Right here, it is doing our face pass. Yeah, right there, it's doing our face pass. And then this here is starting the beginning of our roughing cycle. So that's a lot. Notice that it is not using a G71 or a G70 for that cycle. So that is a bit of a problem. So if we want to use a G70 or G71, we have to do something a little different. Now, why would we do that? Why wouldn't we just use this? Well, let's just hypothetically say we needed to edit that cycle at the machine. This is a lot more difficult to edit. You have to really figure out what's going on there because there's multiple passes at multiple depths. I suppose you could just change maybe the finish pass, but it's not a good way of doing it. So I recommend almost always using, unless you have some kind of crazy shape or something or profile that you need to use this. But otherwise, I recommend whenever you can using a canned cycle. So to use a canned cycle in here, let's delete this. And I'm not requiring you to use canned cycles for your tutorials, but I highly recommend that you do just to get in the habit of using them. So to use a canned cycle, you just come down here to canned. So they have these in here, and you can see you have your G75, you have your G70, your G71. This one here, the pattern repeat. I'm not really sure what cycle that uses. I think that's something different. But anyway, we're going to pick a rough. So I'm just going to go ahead and do the same thing. The same exact cycle. And you can see here, it's asking you for clearance, X clearance. It's asking you for Z clearance. So we usually make this 0.1 when we're programming. We usually make this maybe 0.1. Stock to leave, we can actually make this 0.05, even less really. Stock to leave, we're going to leave 10. On the X, the Z, I usually leave 5 on there just because it doesn't like to plunge in the Z direction very much. Depth of cut, again, that's our U value. So it even tells you your U value here. Well, it's actually not your U value in Haas. It's going to be your D value technically. So your depth of cut, your D value would be 0.1. And you can see here, it's actually showing you kind of an example of what the cycle would look like. So let's go to compensation. Let's put that on control. Lead in, lead out. Now, see, you have a little bit less options here because it's going to do whatever the machine is programmed to do. Now it's not programming those lead outs. It's doing whatever your machine is telling it to do, and that's based on the macro in the machine. So it's going to do whatever that's programmed to do. But we can still extend our lead ins and lead outs. Now we don't want to extend our lead in, but I do want to extend our lead out, and I'm going to extend that by 0.15 again, and hit check. And hit check again, and you can see there, now it's going a little past, and that looks good. All right, so there is our, there is our roughing pass. Let's add our finish pass. Hit check, can cycle. All it's really asking for is a retract distance. I'm just going to make that 0, 0 because it doesn't really matter at this point. We'll make it 0.05 just to be safe. And I'm going to hit check. Tool compensations in the control, and it's automatically defaulting to that because that's what we used in our roughing cycle. And there you can see is our finish pass. So you can see it's higher here. It's just because I added that extra clearance. If I go back to 0 and regen that, now you can see it's normal. So I just wanted to add that so you could see it. I really don't like it like that. Okay, and let's take a look at that. All right, oops. So looks good. Everything looks good there. Now, the way you know that this is good is you should see the radii. And remember, the reason I don't see these radii is because I'm using control compensation. So the radii aren't exactly correct. So that's why you don't see it on the radii. Again, if you wanted to see that, all you need to do is come in to hit computer, check, regen them both, and simulate it, play. And now you can see them pretty well. Now, you can't see it here because the tool nose radius doesn't allow you to get in and make a square corner, obviously. So that's okay. And this is just graphics. You can obviously still see it. So all of that looks really good. Okay. I'm going to go back and change that quick while I remember. That way I won't forget. Regen that. Okay. So there is our part roughed. Now it is time to add these holes. All right, so to do that, what I am going to do, what's that doing there? Oh, never mind. That's a point. That's the point that it's going to. It created that when it's doing the face. That's why that X is there. Thought I accidentally clicked one there by accident. Okay, so let's go to turning, and here we are going to look at some of these, and we don't want to face drill. Cross contour, that's a contour. Cross or C axis contour, we don't want to do that. We don't want to face contour. So we need to take a look and see, okay, so we have a C axis drill and we have a cross drill. So if we select C axis drill, we can then select our points. So let's just start out and let's say, okay, I want to select this point, this point, this point. Oh, why can't I select that? So if you run into this problem, the reason you can't select that is because you have a depth filter on. You have to turn this depth filter off. and that will then allow you to select something that's in the negative Z. Well, I should say in the negative Z for the universal coordinate system. So then you can go ahead and select this one and hit enter. Go get our tool. That is not our tool. We want, I believe, an 1/8 inch, right? We want an 1/8 inch. So let's go find an 1/8 inch. Now I think, if I'm not mistaken, I believe your textbook has you use an 1/8 inch end mill. We can use one of those because it looks like it's supposed to be a flat bottom. So in hindsight, I guess I should probably grab that. But if you wanted to just use a drill, that would be okay too. As long as it's a stub drill and as long as it's a split point drill. Okay, so let's go to the filter and let's turn none of these on, and then let's just turn the end mills on. And we'll get an 1/8 inch flat end mill. We'll plunge that in there. Okay, so let's put like, I don't know, 10 inches a minute. I mean, this is, you probably should go like 15 inches a minute. This is aluminum. Spindle speed. I think the max we can go on our live tooling is 5,000. Okay. Let's go to cut parameters. We're just going to do this all at once. It's only an 1/8 inch deep, so we don't have to peck or anything like that. Clearance. Our clearance is going to be 0.25. It's incrementally from the diameter. The retract is going to be 0.1. That's fine. Top of stock is going to be 0. And our depth is going to be negative 0.125. So I work in incremental when I'm doing live tooling because I want to know where it is at incrementally from my geometry. So I know my geometry is right on the diameter. So I just work completely incremental here. Makes it much easier. If you try to work in absolute, you're probably going to make a mistake. It's really a pain in the butt to work in absolute on these. I don't even really need this clearance. I suppose I could just turn that off because my recheck's 0.1, so that'll go 0.1 higher than geometry. All right, tip comp, don't need that on because I want to have a flat bottom. Flood coolant's on. I don't need any of this stuff. The axis control I do need on, and I need to set my diameter. So it needs to know what diameter I am cutting these on. And in that case, it's the 1 inch diameter here by looking at my print. So I'm going to hit check, and there we go. You can see I have all of my holes getting drilled. All right, so let's take a look and, oops. I want to select those. And play. There we go. Now, that did it extremely fast, so let me rewind it one and slow that down a bit. And the last hole. So there we go. And of course we could do the same exact thing, just do another, we could just do another cycle there if we wanted to countersink them or deburr them in some manner. Okay, so next what we need to do is we need to cut this thing off. So I'm going to exit out of here, I'm going to go to top, and let's do a cutoff. So if we go to our cutoff, I'm going to select my boundary. I'm going to select that back edge here. And of course, I'm going to use my right-handed cutoff, 125 wide. The reason I'm using this one, again, is as explained in other videos. I want that relief on this side. I want it to be straight over here. case I have a big piece of stock so it doesn't gouge into it. So I'm going to go ahead and pick that. Max spindle speed, of course, is 3,000. Surface feet, we can probably run about 500 for a cutoff. All right, entry amount, we're going to go from stock always. It's not really necessary here because we don't have a lot of extra stock. We have 50 thousandths, but I just do it for safety. The retrack I always do from stock as well. Okay, so one of the things we want to do here is we want to put a little chamfer on the back. We do a chamfer or a radius, doesn't really matter. Chamfer's cut a little nicer, so I'm going to go ahead and do a chamfer and put my parameters. So I'm just going to make this like a 15 thou chamfer and hit check. Now, if you were to run this and hit OK at this very moment, it is going to give you an alarm. It's going to run and it's going to have a collision because you did not click clearance cut. It is extremely important you pick clearance cut, otherwise you'll just keep getting it to alarm out. So if we look at clearance cut, I always do this from stock as well. Entry amount, X increment, so we're just going down basically 0.1 past this chamfer here. And then Z increment is just how much past, so 0.1 there is okay. We could honestly probably make that like 0.01 or even 0, really. So I'm just going to leave control on here and hit check. All right, you can see there we have our small little chamfer. So let's go ahead and see what that looks like. And we'll see if I had my cutoff keep stock and part in chuck turned on. I forgot to look at that. All right, there's our part. Nice little chamfer on the back side. So it's pretty much completely deburred, with the exception, of course, of us putting some chamfers on there, which we could very easily do. Your book doesn't have you call for it, so I didn't really go through it. But all you need to do is repeat the drilling process. Just select a chamfer or a countersink and just figure out what your depth needs to be. At any rate, that is all I have for this lesson. So if you have any questions, as always, you can see me during my office hours or, of course, see me during class.